Welcome everybody for our final 2020 Third Thursday seminar. My name is David Stevens, Laser Dave, here to go through one of my favorite course topics, and that is laser hacks. Laser hack is kind of a creation of my own of amalgamations and techniques and tricks and tips that make your laser processing faster, easier, better quality. Just lots of helpful hints and tricks to make your processing work better for you. So just like before, if you've ever joined me before, please feel free to answer or ask any questions at any time during the course. And then at the end of the course, I will go ahead and go through the questions and answer them as they come in. So let's go ahead and get started. This course is not too time consuming today. It looks like we'll probably be about 35 to 45 minutes for this Laser Hacks 2.0 course today. This Laser Hacks course, of course, also like in the past, has QR code links. If you're not familiar with QR code links, all you have to do is turn on your camera app, point the camera at the QR code, but do not take a photo, and a link will show up on your screen. Select that link to get quick access to web links, files, as well as videos that are offered throughout the course. Trotec is also always a very social company. So if you want to keep up with current events, trainings like this, products, applications, laser materials, please scan the QR code and subscribe to your favorite social media platform. We are on YouTube, Facebook, Instagram, LinkedIn, Pinterest, and Twitter. Today's course outline is going to include some speed hacks, several different techniques on how to use acrylic to make a pin table, alcohol with acrylic, low-cost print and cut, sublimation print and cut, metal marking compounds, blue painter's tape, and many other types of topics that we're going to cover details on how to improve processing techniques with your laser system. So let's go ahead and get started here with some just basic speed hacks that I like to cover most of the time. And that is just making sure when you're designing a file with your laser system or for your laser system, I always suggest that you kind of keep certain attributes of that file creation in mind when creating these files. And that includes the way you design a file can dramatically improve the processing time of that file. And here's a very simple example. A simple bar of lines, and this can be lines of text, it can be a specific type of graphic. If you look at this type of graphic, an experienced person knowing the laser going across the grain will take longer than going with the grain in this case. And that is because the laser system takes more pulses going back and forth across the grain. So if I have lines like this, whether it's text or graphics, the laser has to go back and forth over the entire square of graphics here. Where if you turn it 90 degrees, and just because it may not be shown that way in the finished result, you can always turn it back. If you turn it 90 degrees, the process time can drop dramatically because the laser sees the open space between open entities and graphics and ignores that and skips down to the next one. So this is a great example of a simple graphic. Just turning it 90 degrees, in this example, went from over 7 minutes to process to just over 2 minutes to process by simply turning the graphic so that it actually does not waste so much extra time with that open white space. So this is something in a simple laser hack that you can do in your file design to create graphics that will produce faster results, or just orient your graphics to produce the faster results. And so that is one thing that I always tell you to take a look at. And if you're not sure if a direction or an orientation of how you place it or send it to the laser is faster, hit your job estimator, rotate it, and then hit your job estimator again. And your estimations should tell you the difference between that rotation factor and show you which way is more efficient. Another speed hack that I like to promote is color mapping. Color mapping is the process of using your laser's colors. Most will use one color for engraving, one color for cutting. Others may use one or two colors for engraving, but there are times where you can use many different colors, all at the exact same power and speed settings. And so here's a great example. What I have done is I have 4 different colors selected. They're all exactly the same power, speed, frequency, and settings. Nothing is different on it. And so why you may ask that, why did I ever do that? Well, there are times where I want the laser system to be more efficient. So by using the same power and speed settings on a job or project like this, will dramatically improve the process to process this type of graphic. So when you have a very large oblong or awkward type component that you put in your laser system, and you can only place 4 or 5 of them in there. So here's an example. So in this case, I could mark 4 products at a time inside the laser system, where if I leave them all black, what happens is the laser goes between each one of these 2 spaces, taking 42 seconds to run all 4 products. Well, that's great and really isn't not too time consuming, but if you're running these all day, every day, the productivity can be greatly improved by simply changing it to 4 different colors. Each color running the same power and speed, but the difference is the laser system quickly marks in one area, then moves over and marks the other area. So you don't have a lot of excess dead space for that laser system to travel in between the left and right motion between the 2 products. So understanding that sometimes color mapping can dramatically improve productivity by simply changing the color or using multiple colors in your file design, assigning the same power and speed setting to each one of the colors, and then putting them as a different one. So the laser is going to do, in this case, it's going to do black, then it's going to do the red, then it's going to do the blue, and then it's going to do the cyan color in this case. And then so we're now dropping down to 14 seconds, and therefore more than doubling the productivity by the end of the day. Simple projects or simple processes like this can dramatically improve productivity and therefore allow you to finish more products throughout the day. Other simple processes are just learning how to design your file so that you get more efficiency out of that file. And here's an example for when you're cutting a piece of material. There are many times that I need to just cut simple squares or shapes out of a piece of block material. Whether you're cutting coasters out or you're cutting blanks out, it doesn't matter. But in that case, there are so many times, say you're cutting a square, you create your square and you duplicate it, and then you go to cut it out. Well, in this case, here's a great example of where I can take and cut each square out in 12 seconds, in this case on a piece of 1/4-inch acrylic, or I can design my file as one solid large rectangle, and then I can do individual lines down each of the center point. And so instead of doubling the amount of cuts on each square, I'm basically splitting the difference between each one of them, dropping my per product part down to 9 seconds each. And I'm also getting more efficiency out of that material. So because I'm butting them up like this and doing a single line down each cut, I'm now able to get one additional piece out of the sheet size that I used in this example. So just understanding, sometimes when you're designing a file, material is expensive. And when you have expensive material, not only are you going to get more products out of that material, but you're going to get it done faster. So these are simple, basic laser hacks that I have shown for years that really do improve the process. So pay attention to your file design. Pay attention to your creation of your file, especially if you're producing high volume or multiple products over time. It doesn't really save you a lot of time if you do this, because it will take more time to set the file up. But if you're processing a lot of different materials, it will dramatically amount in savings of both time as well as material cost. Here's a simple laser hack that I have used for years. It is called sand trays. Sand trays are a great laser hack that I have used for years. I've actually launching one online as well, a video of this process showcasing the ability to do this. But sand trays are nice because when you have oblong or oddly shaped one-off type low volume products, and you need to place it into the laser system very quickly and efficiently so that it can be run for a prototype, for a one-up type product for a customer. Sometimes it's difficult to hold that product in place, and you'll spend more time trying to get your product to sit flat or hold itself flat in order to laser process it than it takes to actually run. So this is a great thing to keep in your back toolbox. Basically, is a tray of sand. So what I'll do with the tray of sand is just set it into the laser system, set my product down inside the sand, place a level over the surface of it, make sure it's flat, use my red dot pointer to target where I want to place my graphic, snap my graphic to that red dot pointer, and then hit start. So it's a quick and easy, efficient method to create those one-off products for oddly shaped objects. Another one that I come across all the time and get a lot of questions from customers is reflections. So when you're cutting acrylic, especially acrylic and some plastics, but mainly acrylics, when you're cutting it on the vector grids or cutting tables or honeycomb grids, you tend to get these little reflection points or tick marks. These are basically the excess energy of the laser as it's going over the metal cutting table, creating a reflection point on the backside of your acrylic. If you're backlighting or edge lighting the acrylic, or if the customer wants a really smooth looking edge quality, this can be troublesome. And so there are some laser hacks that I use to eliminate this process. There are some cutting tables you can buy. I know Trotec sells an acrylic cutting table that will eliminate this. But if you don't have that and you have a metal cutting table and you do low volume acrylic, here is a great hack that I use and have been using for years. There are little kind of mushroom shaped T looking pin that I have designed and set up so that I can cut them out with the laser, and then I can place them into the laser system onto the cutting table, and I can elevate the acrylic to eliminate these little reflection points. So here's a quick video to kind of show the process. I have a couple different thicknesses here. This is an 1/8 of an inch thick piece of material for your smaller cutting table, like honeycomb cutting tables. But what it does is it literally slides in, giving you a nice little groove. It doesn't move left, right, up and down. Thicker cutting materials, if you're using the large vector grid type cutting tables. So these are going to allow you to cut down inside and again, drop them down into the area or into the area that you want to do. And then you're going to go ahead and place your acrylic over the surface of this. This is going to give us still the downdraft or vacuum, so the exhaust is pulling through the cutting table, but it's elevating it at least a 1/2 inch off that cutting table so that when we're finished cutting it, the finished product will drop. And then when we look at the edge, we're not going to see those little reflection points on the backside of the acrylic, giving us that nice finished flame polished edge that can be edge lit. It can be seen from a distance, and you're not seeing that pattern of reflection points or tick marks, basically heat distortions on the backside of your acrylic. So that is a great little one here. If you want this file, of course, I always give you my files here. So scan this QR code. Again, turn your camera on, hold your phone to this QR code, and it's going to take you to a Dropbox link, and you can download this file in both a CorelDRAW format and a PDF format. PDF format is a vector format that can be imported into CorelDRAW, Illustrator, most of your graphic design type software as a vector format so that you can cut these out yourself and make a 6 of them or so, and then just put them in a bin and use them as needed. Sticking with acrylic here, there is one big no-no that I always want to kind of showcase here, and that is using alcohol with acrylic. So many people do not realize that when you clean acrylic with alcohol, it can actually cause damage to the acrylic. And this is nothing to do with the process of lasering or cutting. It is a chemical reaction that tends to happen from the reaction of the laser after it's been done. So I highly suggest that you stay away from any type of alcohol-based cleaners or paints when paint filling or cleaning acrylic or pretty much any plastic. Because what happens is when you go to clean it, and over time, and it doesn't happen immediately, so you don't even realize that the alcohol or the cleaner is the cause in most cases. But what happens over time is that you get these little micro fissures or fractures that will start forming on the edge. If you're using an alcohol-based paint and you're paint filling an area, all of a sudden around the edges of the paint fill, you'll see these same little fractures and kind of fissures that will start forming. This is from a reaction from the alcohol in reaction to the acrylic. This can actually cause damage to most of your types of plastic, especially even like your engraver's plastic or engraving plastic, like your Trolets, your Romark, your IPI, your Gemini plastics, because those type of plastics are largely acrylic in their component or in their making. And so stay away from alcohol-based cleaners. And this is a laser hack that I get a lot of people saying, you know, every time I clean my alcohol or my acrylic, what happens over time is I start to see these little fractures. They think it has to do with the lasering process, but it has to do with your cleaning process. A great alternative for that is hexane materials. Hexane materials, this is a great example, cleaned in alcohol after 1 day. You can see the alcohol right now. You can see the little fissures and fractures showing up on the AB here. And then also clean with hexanes after 1 day. Hexanes is it's a petroleum-based cleaner. And the petroleum-based cleaner will not actually cause these because the cleaner is made from petroleum and acrylic is made from petroleum, so they tend to react very well to each other. Here's another example of that. Here's a quick little kind of video to kind of show you the close-up example of exactly what the alcohol is doing to the acrylic. This is something that I have been plagued with for years, and there's so many different chemicals and cleaners and paints that are alcohol-based that will cause this type of fracturing and flaking or just reaction into the surface of the acrylic. The longer and the more cleaning elements that you actually use, the worse it's going to be. And of course, the sample I just show here is something I took this letter A and I dropped it into alcohol and let it sit overnight. So it really, really dramatized how bad it could actually get. Hexanes is the way to do it. If you're not familiar where to get it, you can pick it up on Amazon. I get it from McMaster Carr. It is very inexpensive. It is not available, unfortunately, in California. You have to find it locally because it can't be shipped. It is a petroleum-based cleaner. A McMaster Carr, it's about $23 a gallon. And it tends to take me years to go through an entire gallon. So if you can't find hexanes, then heptane, Heptane, heptane also works just as well. It's a derivative of the same type of formulation. This came about from a chemist that I worked with for years that actually found this process work really well after so many people had complained about the alcohol problem. Okay, moving forward here. Another question I get all the time is, how do I do print and cut, but I want to do it inexpensively? Print and cut is something that is becoming more and more popular as laser systems have the ability to, of course, take a printed object and then physically cut that object out. So if something is printed on woods or plastics or fabrics or apparels or leathers or acrylics, the laser system can, of course, cut it out. Well, this is an outstanding capability with laser systems, but the problem is the printing technology can be very expensive. And if you're doing it all the time, it's definitely lucrative and worthwhile in moving forward with a UV style printer or a solvent-based direct-to-material printer. But most people that want to do it from time to time don't have that ability, nor they do want to spend the time, effort, money, and training on developing themselves into a full direct-to-material printer. So the ability to cut out these materials with the laser still is there. And so the question I get all the time is, how do I do that? And so I've got a couple different laser hacks here. If I take this simple little print file, and I want to actually cut this out. So what I'm going to do, instead of printing it directly the materials, I'm going to invest in some simple application, a double-sided tape. And double-sided tape, you can buy it in rolls, you can buy it in sheets. And in this case, I can literally just take some tape and I can place it onto a piece of substrate, wood or acrylic, and I can use my common everyday inkjet printer and print my object directly onto it. Another method, if you don't want to use the double-sided, that I like is the Xyron machine. Xyron machines are great because they're going to take, and if you have something like a printed object and you want to add adhesive to the back, instead of rotating or placing the double-sided tape directly onto the substrate. In this case, you can place the double-sided tape directly onto the back of the printed object. Either way you do it, whether it's the double-sided tape on the substrate like I showed before, you wouldn't do both, you do one or the other. So we would either take it off like this and then just put regular paper, printed paper onto it. But either way you do it, you then gives you the ability to basically peel and stick your printed object onto a hardened substrate. Something like acrylic in this case, or wood, or plastic, or cardboard. Then we're going to go ahead and place it in the laser system. We're going to use the camera, if you have a camera system, on your laser system to find the registration points. And then the laser system is going to size, scale, skew, and rotate the design file to give you that perfect laser cut. Now, this is a great feature, especially if you have a laser system with a camera option, so you have that accuracy and detail. In a little bit, I will also show you a method of doing this if you don't have a camera option with your laser system. So this is basically taking and printing the object onto a standard paper using a Xyron machine or double-sided tape on the back side of your material, placing adhesive on the substrate of the material, combining it together, and then using the laser to cut it out. So a very inexpensive way of not having to outsource your printing to a direct-to-material printer, and then allows you to do substrates and physical hardened objects for signage, point of purchase, novelty, gift type items. If you're interested in a Xyron machine, they're inexpensive at $43, the largest machine. Some of them will add adhesive to the back, magnets to the back. Just a great little machine tool to have in your toolbox. Inexpensive, and it'll really kind of just quickly adds that adhesive to the back. They have one cartridge that adds adhesive to the back and lamination to the front of the print. So you have a laminated surface, adhesive back, you peel and stick that to a material and you can work, or a magnet to the back and adhesive, or a lamination to the front. So lots of different modules. Again, a nice tool to have in your toolbox if you're going to be doing a little bit of this stuff, but not expensive. And that's what it comes down to: inexpensive print and cut. Another method of doing print and cut is some folks out there have a sublimation equipment. And sublimation equipment is typically sublimated on, mouse pads and coffee mugs and stuff like that. But there are also materials out there that are laser friendly. You do need to be careful in this case because a lot of sublimation materials are not laser friendly. What I mean is a lot of the plastics that they supply for sublimation are made of polyvinyl chloride, or PVC. And folks know, most people should know PVC is harmful to the laser because it will produce chlorine gas and damage your system. However, there is a material out there that I have found sold, made by Unisub, sold by JDS Industries and Unisub. Here's this QR code if you want. And what it does is it gives you the ability to use your sublimation printer, if you have one, and convert it into a printable object that can be sublimated onto a hardboard and then cut out with your laser. So a much more inexpensive printing technology than a direct-to-material printer like a UV printer. We're using existing sublimation printing technology. We're able to go ahead and print the object. Sublimation technology basically uses a heat press to heat press the graphic directly onto the hardboard. And then just like before, we're going to take our graphic, convert it to an outline using two different files, one for the print and one for the cut. Use the camera registration again to register our registration point, and then go ahead and cut it out. This hardboard stuff I really, really like. It does kind of stain a little on the surface, but because the hardboard is really glossy in its look, it wipes off beautifully. So as soon as you're done, you can just take a slightly damp cloth and wipe it right off, and you get this glossy, finished, beautiful, sublimatable products. And they've got that sheen and shine to them that really can't be produced any other way. So if you have the technology, or if you have a laser system that can be, a camera registration can be added later. Here's another sublimation to where I took just a simple photograph that was sublimated. And now if I don't have a camera registration, I'm going to take my red dot pointer, and then I'm just going to make a square slightly smaller than the graphic itself, and then I'm going to go ahead and cut it out. So this is a case where if you don't have a camera, you can still use your sublimation and cut out and give yourself an edgeless cut, giving yourself a little bit of bleed. Bleed meaning your square or your cut is slightly smaller than the actual photo itself in this case. Here's a third example of a sublimation on, again, same hardboard, but in this case, same thing. Red dot pointer to target the corner, and in this case, I'm going to just cut it into a puzzle. Puzzle is a great process. Here's another laser hack before you pick all the puzzle pieces up. Take your double-sided or your application transfer tape, and then you can pick up your puzzle all in one piece. And then you can, of course, wipe the back side. So now you have a sublimated laser cut puzzle. Very quick process, very easy process. Sublimation technology is not near as expensive as, say, UV printing technology, but it is a lot more expensive than, say, just your standard inkjet. So that is two different methods to create inexpensive print and cut technology utilizing standard printing technology and sublimation printing technology in order to send to your laser and now create different applications, products, materials for promotion in this case. So that's a great method of doing that. And I really like the sublimation one, especially with that hardboard, cutting out little statues and puzzles and lots of cool stuff like that. So it's a great, both of these processes work very, very well. The next one I have here is, I get the question all the time, another laser hack, when I engrave using metal marking compounds. Metal marking compounds are your Surmark, your Thermark, your laser bond compounds. These are a spray type product that basically you spray it onto a raw piece of metal or an unfinished, or I'm sorry, an uncoated piece of metal. It has to be a raw metal, no clear coating on the metal. And it's basically liquid ceramic. And when the laser hits it, it bakes that ceramic and actually melts the glass into the surface of the metal, giving you a laser mark into metal, where a typical CO2 laser won't typically mark into metal. So this is a great method, and this has been around for almost 20 years, the ability to actually mark metal with a standard CO2 laser. However, the question I get all the time is, especially with higher wattage lasers, is after you're done marking using this process, the engraving or the marking process, after it's washed off, is not as black as you would like it to be. So that dark black, it tends to be more of a grayish in color. And what I have found through just working with people, and I found this out through one of our customers, that when you take that grayish type material and you gently wipe a material onto it, or an oil onto it, coconut oil, believe it or not, it will dramatically darken it and keep it dark over time. It seems to bond to it and keep that actual graphic and make it much, much darker. And I'm not certain exactly why this works. You can even do one with and one without this oil, put it through the dishwasher 5 times, set it side by side, and you can clearly see which one you rub the oil on. It just looks more rich, darker, and it just gives you a cleaner, more smoother, more consistent look. Anytime you have black plastics and anything like that, the coconut oil seems to work really, really well when making dark blacks look blacker. I have a laser hack video online that showcases this same process on plastics. And so if you've got like an engraving plastic, like a yellow surface with a black core, for example, and it kind of comes out grayish. And this is because of the way the laser tends to frost the plastics. But also on the metal marking compound, take a little bit of coconut oil, rub it on. You can see the difference. This photo is actually taken side by side, one next to the other. So this is not superimposed or anything like that. It is literally 2 pieces, one done, one not done, at the same place in the same photo booth. So you can really see the difference between the process just by rubbing a little bit of simple coconut oil into the engraving. Okay, here's another laser hack that works very well. There are cases where you need to proof something, confirm that a graphic, an image, or a logo is going to position itself correctly onto a product. Say you're engraving onto a guitar body and you don't have a lot of extras laying around, or a box or some kind of heirloom that you want to make certain that the orientation and look is correct. Well, this is where I would suggest using standard off-the-shelf blue painter's tape. Blue painter's tape has a very interesting effect that when you laser engrave it very lightly, it gives you a nice bright white effect. And so when you place it onto an object and you want to proof something, make sure it looks good, it's in the right orientation, the graphic is outlined correctly, place a little bit of tape over the surface of it, and then use the standard paper setting in your materials database or a very light laser power setting, and then laser engrave it onto the tape. This is going to give you your positioning and orientation to make sure that it looks right before you actually damage or affect the actual product behind it. And here's an example. I'm going to take it and I'm going to actually peel it off here and actually show you behind after I have actually stuck it in the laser to show you what it has actually done. It doesn't actually damage or distort the backside or the actual material itself. So you get that nice finished. If you don't like it, you can of course peel it off and start it again. Or if you do like it in place, you can then bump your power up to your wood setting in this case and engrave right through it. Or if you have a template or something like that, or if you like your orientation, you can peel the tape off and then of course engrave that. If you leave the tape on, and if you need to color fill it, now you can do that as well. So color filling is going to give you the ability the tape is of course going to do what it's designed for, and it's going to mask off the surface. And so in this case where I didn't get a great contrast, I can also paint fill it. So the mask does two things. It gives me orientation and positioning so that I know my orientation is correct. And in this case also gave me a mask for paint fill. So kind of 2-for-1 operation here. So if you are doing something and you want to know it's going to kind of fit right, go pick up some standard 3M blue painter's tape at your local hardware store, stick it over the top of your product, focus onto it, lightly engrave. And if you're not sure on power settings for the tape, I would suggest trying it on something or even sticking a piece of tape right onto your table first and engraving it to make sure you don't go through it. You don't want to accidentally damage your product, especially if it's a one-up prototype or test product that you are processing. So make sure you have your setting correct before you do that. But this is just a great laser hack to help you orient, prototype, and position your graphics before you actually make it real and engrave directly into the material, basically requiring no way to actually go back from it if it doesn't look right. Okay, next up here is a multi-level engraving laser hack. This is another one that I get all the time. Is if you have a product or component or device or something that you're engraving on where you need to engrave multiple levels onto it. Most will focus onto one level, engrave that level, focus onto another level and engrave another level. But laser systems and pretty much every brand out there has the ability to do all the levels at once. And that's what this laser hack is to do. So I have this simple little bamboo spice rack. And I want to engrave a graphic on all 3 levels at the same time. And so what I'm going to do is I'm going to use the laser's color mapping technology. Kind of like I showed you earlier where I use different colors for different to speed up the product. Where in this case, I'm going to use the same power and speed settings, but I am going to assign a different Z-axis to each color or a focus point. So what I'm going to do is I'm going to manually focus on each one of them, and I'm going to write down the Z number that the laser system gives me on each one of these numbers. Then I am going to go into my driver, and I'm going to assign the same power and speed, and I can use the standard wood setting onto each one of the different colors. And then I'm going to assign the offset Z number that the laser, or the computer told me when I manually focused. It'll tell you what it is. And then I'm going to go ahead and engrave onto it. And in this case, I'm also using the blue painter's tape to kind of showcase how I was able to position it here using the painter's tape as well. But in between each one of passes, the laser system is going to automatically adjust the Z. So therefore, I have the finished kind of result, and I've now proved the concept. And here it is where I placed it back over the product, and now I'm engraving it, of course, directly into the material itself. So as it finishes one color, and you want to make sure the colors are in order that it doesn't accidentally hit it. And so the laser system is going to engrave in the order of the color palette. So it'll do black before it does red, and red before it does blue. And so in this case, I know that I need to start on the low end and then I can start on the high end and then I can kind of step down. So each one of the colors are processed, and then I use a third color or fourth color in this case, because the laser system will like to go back to its original home position at the very end. And so I will use a kind of a sacrifice color with 0 power so that the fourth color moves the head away and it doesn't accidentally hit the product after you're finished. So this does take a little bit of trial and error, a little bit of practice in doing that. And so if you have an object or component or a product like this that requires multiple levels to be engraved at the same time, with one push of the button on the laser system will have the ability to engrave with your same power and speed setting for each level, but each color is going to be done in order, and then it's going to actually refocus to that different focus point as it goes through different colors. You don't have to measure it. Like I said, use your manual focus tool on each one of the levels. And on the computer, it's actually in the driver for the laser system. It'll tell you what the Z height is for each one of the levels. Make sure you write that down based on what color you're assigning it to, and then you're good to go. Then a little bit more setup on something like this. Not worth it if you're doing one, but if you're running products, or maybe you're doing something like this for Christmas presents or for sale, it's definitely worth the time to set this type of a project up and use that type of laser hack and use the lasers technology to do multiple layers or levels in Z-axis levels at the same time. Same type of project is something like this, where if I have an object like this and I want to use different focus, I can do the same type of thing, but this is typically going to be done manually. So in this case, I have a nice curved black river stone and I want to engrave something across it. Well, lasers don't like to stay in focus. And so what I'm going to do is I'm going to focus my graphic onto the surface of the stone, and then I'm going to refocus about halfway through the material and then run a second pass on something like this. And so using focus, using your Z-axis on each one of the different levels, in this case, allows me to actually get more curvature around an object itself. So focus is a kind of a great little thing, and I'm able to get a nice finished result for that. Again, laser hacks, really knowing how the laser is going to respond. Something like this process, I would not suggest too much detail in a graphic, because you are splitting the difference of focus. If I went to the low point, the high point wouldn't engrave, but I can do it in 2 separate passes at 2 different focal points, and I can get basically more curvature around an object on this river stone, for example. Okay, next one here is a sandblaster, another inexpensive, low-cost way to clean woods. You may think, well, why would you clean wood with a sandblaster? Well, sandblasters have a unique capability that I have found based on experimental testing that really do a good job when it comes to process or to cleaning, especially 3D type marks into woods. Sandblasters are inexpensive. You can pick up a little handheld one like this. Harbor Freight has one I found online that's for under $20, which is crazy. You do need, of course, an air compressor for this to work, and then you're going to need some sand. I do actually buy like the glass bead sand, but I mean ultimately any sand will work in this case. But the reason I suggest getting one of these is if you have a plan to do any type of like depth engraving into wood. And here's a great example, 3D. 3D, when you clean 3D type graphics with wood, it can warp the wood. Well, sandblasting will eliminate all this residue without warping the wood. And so in this case, I've taken a 3D, I'm running it in relief mode, which allows the laser system to pulse into the material and vary the laser power based on the shade of grayscale, giving us that 3-dimensional image coming out of it. And I will typically run multiple passes so that we don't get too much residue. If you run really slow, it can actually burn your wood. So more passes are always going to give you a better quality. But even still, as you can see here, as I cut this product out, the material itself is really dark. I could scrub this off with water, but then my wood would warp and I'd have to clamp it down and flatten it and let it sit for a couple days just to keep it flat. A sandblaster is with pretty much very low pressure, allows me to very quickly go over the surface of it, and it's going to just take off the residue and the burning effect that you get from that. It only took me, 30, 40 seconds to actually sandblast this entire graphic. and take off all that residue onto the surface of it. And so I'm able to take it out of the laser, stick it, take a sandblaster, and then sandblast all that extra residue, and then I need to add the oils, of course, back into the wood. So it's just some standard furniture oil over the surface of it. And here's the actual comparisons that you can see. So simple process, inexpensive process, before and after, a dramatic improvement. My wood stays perfectly flat, and I get this three-dimensional pop-out cherry wood graphic that really can't be done any other. I mean, I could wash it with water, scrub it down, and then wait for days and put it under a clamping system, let it wait for days to dry out so that it comes flat. But even then, I have found that a lot of wood will still stay a little warped. This is a great method to keep those woods clean and give you that clean finish result and beautiful effect as well. You don't want to use too high a pressure with your sandblaster because you want it to just take the resins off, but not really, the excess sand energy just bounces off the wood, and so it doesn't actually damage the wood. Too much pressure will potentially damage the wood and pull some of your detail away. So there is a little bit of threshold that you would do. I typically like 60, 80 PSI using some light grit sand, and then keep your nozzle kind of farther away so you don't actually damage the wood itself. And I would practice on some woods to be sure, to make sure that your settings are right on your sandblaster. But it only took me about 10 minutes to figure out what worked the best. And from then on, I have been going back and forth. I did also buy an inexpensive $200 little sandblasting cavity to kind of contain the sand. But all in all, I have a total investment of like $250 into my sandblasting cabinet. If you already have a high-end sandblaster or a sand carver, that will work as well. Just again, control your pressure and then take your engraving and then cut it out, or sandblast that detail away. Another one that I get all the time is when you're engraving raw wood. Raw wood would be wood that is not finished with any type of clear coating, such as a varnish, polyurethane, lacquer coating, or something like that, or paint. And so when you engrave those types of woods, especially something like plywood, we actually tend to get a lot of residue and debris that form onto the surface of these materials. And you cannot wipe that off. If the wood is finished with a lacquer, a polyurethane, a clear paint, a varnish type material, that excess debris and residue can be taken off with a damp cloth. Well, sometimes that is not possible, and sometimes you still want that detail into it. And so when you're doing larger graphics, this is a nice large 12 by 12 graphic, you can also sand the surface. You got to be really careful when you do this process. So here's a case where I have a nice 12 by 12 piece of raw plywood. And plywood is unfinished, so there's no clear coating, there's no lacquer coating on it, there's no varnish onto it, and we're going to engrave a decent amount of depth into it. This image looks like it's quite detailed, but because it's so large, there's really not too much detail. And the reason I say that is because if there's too much detail, this process will not work. Too much detail, a sander will take off the details and break all your little pieces. So you can kind of see with my hand in relation here what size of the graphic it is. And so in this case, it is definitely permissible to, of course, use a orbital hand sander to get those details back. If I tried to wipe this off, it just wouldn't happen. So I tend to use 150 to 220 grit sandpaper. And when you sand it, you want to keep it very flat. Keep your sander extremely flat as well. Don't try to angle it at all because you'll immediately break details. You'll also take off components or sand some of those details into it. So in about 30, 40 seconds of actual sanding, I'm actually able to take that. And this is another reason why we want to engrave with some depth into this type of material. So we're not going down inside. We still want the contrast. And then I'll take just a air compressor and blow off any excess sawdust. And now I'm able to get that. And so if something is not able to be clear coated, and you're not able to do that type of stuff, maybe it's going to be a cutting board, or maybe it's just a decor, or you don't want to spend the money on the cost of lacquer coating it, then definitely something that is possible to do with your with a hand sander. Just be very careful when you do this. Keep everything very flat. Be very careful that you don't have too much detail, because the sander is notorious for breaking off that detail onto woods and stuff like that. And so larger products, definitely. Smaller products, I would use some of my other laser hacks, which is like placing mask over the top of it and then engraving through it, and then using duct tape to peel the mask off. I already have a laser hack online on our YouTube channel that kind of explains that. Here's a big one. This is one I have been struggling with for close to 20 years. The problem of having acrylic flare on me. Well, acrylic is notorious for causing flare-ups and flame-ups. It is the one material you want to keep incredibly close vigilance. You should never leave your laser unattended anyway, but acrylic, you want to keep your eyes glued to it, especially when cutting thicker materials. And this is because when you cut thick acrylic, especially thicker acrylic, it tends to like to flare up. And so there's been all kinds of tricks out there. I mean, using air assist, we've tried nitrogen gas, we've tried all different types of stuff. And I've tried trick after trick. I've downdraft vacuum tables. I've skirted around it, created more vacuum, more air. Nitrogen will actually help a little bit, but all of them were kind of had the inability to really douse the flame. And so I've been playing with different techniques and capabilities for, like I say, for literally 2 decades. And then one night, something simple came to me. What is the main reason why we get the flame? Well, that's because we have too much heat buildup. And so the ultimate goal is, of course, we need to reduce the amount of heat when cutting through the material. We need enough heat to give us that beautiful flame polished edge, but we need to keep the heat down on the back side. And so what I found is super simple, and that is simple paper or paper towels, believe it or not. So with paper towels, what I will do is I will take 3 to 4 layers of paper towels or even wet newspaper. I will literally leave it dripping wet. And I will place that onto my cutting table. I will then place my acrylic onto the paper towels. And then I will go ahead and cut it out. And so this is a 10 millimeter or almost a half or 12 millimeter, half an inch piece of cast acrylic that I'm cutting out. And I would typically always see some type of flare, especially on an 80 watt when cutting this thickness on the back side. Well, the paper towels absorb any excess heat and energy. It also reduces the amount of reflection points I see on the backside of my cut. So it's kind of like a 2-for-1 bonus. You can also use the pin table hack that I showed you earlier if you are doing extra thick material and have a lot of extra power. And then, of course, place the paper towel, wet paper towel, 3 to 4 layers, needs to be nice and wet. And then place your thick acrylic over the top of it. And this is going to, of course, elevate it, even reducing the chance of any type of flare. But the thing I like here is to show you is you can actually see what's happening. The laser beam is going through the acrylic. The beam is hitting the paper towel. And because of the moisture in there, it's actually exploding into steam. Well, steam is encapsulating all those components or the vapors from the acrylic process and keeping them from flaring up. And so that's what's actually keeping the flame from happening. So it's not that there's not just as much gas that's ignitable in the back. It's that the amount of moisture or humidity in the underneath side has dramatically increased, reducing any chance of flare up. In all my lab-based testing for over a year of doing this test, I have yet to have a single flare up. And here is an example of 3/4 of an inch or 20 millimeter acrylic cutting the letter B on wet paper towels with an 80 watt laser, which is unheard of. I mean, this is pushing it to its absolute limit. It took like 25 minutes just to cut this letter B out onto my laser system. And again, I would never, ever even attempt something of this thickness with an 80 watt laser without this process. And the exciting thing in this video when I created this was this right here. After I took and cut it out, I took a look at the paper towel after it had cut 3/4 inch acrylic, taking 25 minutes, and that excess energy didn't even penetrate through that paper towel. So it's absorbing all that extra energy. It's converting it to steam. It's eliminating the possibility of flame on the backside in my lab-based settings. I'm also have a good vacuum going down through this. I have a good exhaust system. I can't guarantee you won't have a flame, but in my experience, based on extensive testing, this process has eliminated all flames on the backside, pending I had a thick enough paper towel, good enough moisture level, and I wasn't doing too large of an area. When if you try to cover up the entire field and you're cutting for hours, it could potentially start drying out, and that could be a problem. And I should warn you right away that more testing would need to be done on how many layers. I've also tried 5 and 6 layers of wet newspaper, which is inexpensive. You can buy it recycled, and it worked just as well. Again, has to be soaking wet on the backside. A little bit of moisture on your cutting table is not going to hurt anything. It's made of aluminum. And then we're able to just go ahead and cut these materials out. So that is a great laser hack for, in my opinion, eliminating flame from my experience so far when cutting very thick acrylic. Here's another laser hack that I have kind of figured out over time. I get the question all the time. I'm running I want to run multiple laser tumblers on my laser system. So most rotaries are kind of designed to run one product at a time. What that means, you stick your tumbler into your rotary system, you focus onto the surface, and then you engrave it, and then you pull it out and you repeat. So it is kind of very inefficient. And because it takes so much more time to run one at a time than you can run, say, 3 at a time. And so I found these simple little gasket components on Amazon that literally allow the tumblers to kind of press together. And so here's a QR code where I got them. They were like $6 for 3 of them. And I don't give these away. These are used as a template. I take my tumblers and I press them into that. And then I'm able to then stick them into my rotary and engrave all the time. And so here's how it works. We just take these simple little components, and they're designed as a product to basically give you a skid-proof base. But instead of doing that, I'm using it as a component, as a template to kind of hold them in place. And so when you press fit these together, they become very, very firm and kind of hold themselves into place. So much so that I can grab the actual component or grab this as one product. So you can see I'm taking it with one hand, and I'm able to stick or place 3 products in at the same time. And in this case, I'm going to engrave 3 different graphics onto 3 different cups all at the same time, just by, of course, measuring the distance for each one, turning on my rotary, and then, of course, engraving all 3 products at the same time. If, of course, it's the same graphic, the laser would, of course, do a full stroke right away. But in this case, a couple of the graphics are a little bit larger. But this is going to give me the ability to do 3 times the productivity, because we're not taking and stopping, opening up the laser lid and resetting every time a single product is run. This is your traditional standard 20-ounce tumbler, which is probably the most common. But this process can also be done on the 30-ounce as well, which is the larger one. Once it's finished, of course, just pop it out of your rotary system and then pop the pieces apart. And then we now have our finished result. So we were able to take and actually triple our productivity just by buying a few dollars worth of simple little gaskets, or no, not gaskets. They're like a skid base that you can buy for your tumblers that are a very common off-the-shelf product. It's designed for one thing, but I'm using it for a kind of a holder template. I only had to buy 3 or 4 of them because I'm not actually giving them out. I'm using them as I'm running production. So that is a great way to do this. 30-ounce, of course, is going to work as well. I don't really need those for the 30-ounce because they kind of stack together internally as well. You have to hold these a little bit better. But again, if you're doing 30 ounces, pending it, you're not running too far down it, you can kind of slide the 30 ounces together, stick it into the rotary, make sure it's really, really tight into the rotary, and then, of course, engrave all 3 at a time as well. So this is a good laser hack. This is, of course, going to work on materials like tumblers that are pretty consistent in their height and they don't angle too much. I will focus kind of in the center, average it, because we do have a little bit of an angle when doing this process. But so your graphic can't be too detailed. If you're doing like a hyper photograph or something onto it, or wrapping 360 degrees around it, this process will not work because we would need to angle the rotary up and we would need to counter the entire process. But if you're doing a simple graphic or logo or a corporate logo onto multiple cups at a time, this will more than triple your productivity, because not only are you running 3 at a time, the head is taking the same amount of strokes to do 1 product as it is to do 3, and we're not only changing it out 1/3 as often. So it is just a compounding method to dramatically improve your productivity when processing this kind of application. Okay, I think we're getting to about finished here. I did come across this the other day. This is an outstanding resource, and I'm actually going to do a video hack on this one as well, because I just started exploring. I came across this website the other day. It's called Maker Design Lab, and it's a free site run by a lady run by an organization for like your maker spaces. And what it gives you was outstanding. What it does is it gives you the ability to access free file generators, generators to create boxes. And so if you want those little dovetails that create a box, all you have to do is just open up this website, go to the file generator to create a box, and it'll actually add the little fingers offsetting for the compensation of the beam diameter and the material thickness, and you can identify how big of fingers, and it'll literally give you an outline box to cut on your laser. It also has a puzzle generator, and so you can identify how many pieces of the puzzle and immediately give you a single line vector cut specifically for lasers to cut out a puzzle. Place your puzzle over something like we did earlier where we took the sublimation printer. You now have your puzzle outline in however many pieces that you want using a generator like this. The other one they had is gears. So you need a gear that meshes together, has a certain amount of teeth or size. It automatically generates a laser cut gear that you can cut out of Delrin or plastic or acrylic. Another one was mazes. And so you can have these like laser cut mazes where you can put little, make toys and other stuff like that. Again, it generated all these. It was free, as well as they offer nesting, a generator, and it has all kinds of free projects, experiments, tips and tricks and stuff for lasers. So an outstanding resource out there for you. Scan this QR code, go to this website, take a look at it. I'm going to play with it a little bit more, maybe do a video early next year on our Laser Hack site to kind of showcase some of the cool things that I have found from this outstanding website. Now, if you do want to keep, of course, in touch and keep up with it, I do suggest that you please subscribe to our video YouTube channel. Right now, I have almost 20 laser hacks that we didn't cover here today online already. These are individual videos that are 1 to 3 minutes in length that will explain different techniques, tricks, tips on software and hexanes and cleaners and stuff like that, so that you have the ability to do all kinds of fun stuff with this. So scan this QR code, see and subscribe to our YouTube channel so that you'll be kept up with all these new laser hacks. The seminar we just covered today, a lot of these will also be converted into full feature-length individual videos as well. So you'll see a lot of the videos the processes I just covered in this seminar also being added on to it as an individual video as we go into next year. So make sure you subscribe, because I definitely have a lot more tips up my sleeve, and so the future definitely is bright if you keep up with our YouTube channel for keeping you into all those tips and tricks to make yourself more efficient, improve your quality, and just give you an overall sense of understanding of all the little nuances of that is lasers. Deal of the month, if you are interested in materials, of course, Trotec, of course, has our own material site, engraving-supplies.com. November deal of the month is $25 off a purchase of $100 or more. And so if you want to scan this QR code for the rest of the month, of course, the voucher code, just so for you members, is NOV-promo-2020 is the promo code, which will give you this benefit. If you missed last month's Third Thursday on laser processing plastics, that was a long one. It was like 2.5 hours, but it really gave you an in-depth exposure into all things plastics, laser plastics. So if you are working with any type of plastics, I do suggest that you scan this QR code if you haven't seen this seminar already. You can, of course, now, because it's recorded, skip to any specific section that you would like. If you want to talk about engraving plastics or acrylics or Delrin plastics, I definitely go into in-depth components or methods of how to process each one of these types of plastics. Great information. All of our other laser or our Third Thursday seminars, this is the last one we're going to do this year. We're not going to have one next year or next month because of the Christmas holidays. It tends to interfere with the Third Thursday, but we will be starting back up first of the year on Third Thursday in January. So that's it for our seminar right now. And we're going to now go ahead and go live here. And I will ask cover any one of the questions that we have left in the course here today. All right, let's get it going here. Looks like we have lots of different questions that came in online here. And so let's go ahead and get started. Wouldn't the sand get sucked up through the ventilation system? Oh, that's a great question. Yeah, I believe you're referring to the sand-based laser hack that I showed you before. The sand is heavy, and in the case of where I have placed products into it, your exhaust should not have anywhere the amount of flow in order to pull that sand out. I see no movement whatsoever on the sand when I use that laser hack for holding the sand into place. If you're using a really, really high-end exhaust system and maybe a lighter sand, but I tend to use the sand that you buy at like a home improvement store, which is designed for pool filters, which is pretty large and coarse. The other thing that you can use too, if you don't like sand or if it feels like it's a little too light and you're worried about that, I've used popcorn seeds. I've used rice. Ultimately, it comes down to you can use small pebbles, just enough to kind of hold your product in place while you're cutting or engraving it. Okay. What is that called? Sublimation or the sublimation hardboard. What is it called? That was I had the QR code actually on there. It's a hardboard made by Unisub. It's basically a hardboard. So if you scan that QR code or go to JDS and type in the word hardboard or Unisub and type in hardboard, that is what it's called. And it is a sublimatable. It is basically like an MDF hardboard with a plastic like white coating on the surface designed for sublimation. Next question. I use a Speedy Flex and I'm looking at market cast aluminum with an incompatible coating of powder coat from overspray. Which CO2 or Fable would provide better results? Okay, so you're basically looking to remove or ablate the powder coat from the material itself. This can be tricky. Of course, a fiber laser is always going to do a better job because you punch through not only the powder coating, but into the metal itself. But sometimes if you don't want to distort or damage the metal behind it, the CO2 works better. I do suggest on the CO2 laser, a lot of times with powder coating, because a lot of your energy is reflected, and so you don't get a clean removal. Sometimes it is best to either use like a magic eraser on it afterwards and it will clean off that excess material, or hit it with a second laser pass to give you a clean response. A fiber laser will give you a more concise mark into it, but it will take longer, where a CO2 laser will not damage the metal and take the coating off, but sometimes maybe take 2 passes or require a removal of a little bit of that excess material. So there's no quick and easy way to take the powder coating off without having little bits of laser hacks to do it. I do have a laser hack that kind of showcases that, using a magic eraser to clean any excess residue off of it with a little bit of water or even some kind of basic cleaners. I'm going to be adding that one to our video online here shortly as well. So stay tuned for that. Where do you find the different Z-axis numbers? That's a great question. If you are using a laser system that has the ability to do multiple colors, in the color section, so if you're not using the standard materials database setting, if you just pick, say, wood and cherry wood, of course, it's not going to give you access. You need to go into the actual parameter settings where it shows you the power, the speed, the wavelength or frequency of the laser, or the PPI of the laser. Typically in there, it will allow you to adjust what's called Z-axis. And at least on the Trotec, the Z-axis number is right there. It should be set to 0. If you take that into either a plus or a minus, the laser will go up or down, depending on whether you put a positive number or a negative number there. Each color offers that. Now, if you're using a different brand, you would, of course, need to check with your manufacturer to make sure that your laser system has the ability to control Z-axis with colors. But most major brands do have that ability. Some of them, however, are shut off, and you need to have that feature turned on. We're looking to buy a 5-inch lens, but I've been told that it's fiber only. What would happen if we accidentally use a CO2 laser through a fiber lens? Very bad things, actually. I've done that accidentally, and I will take the heat on that one. If you accidentally fire a CO2 laser on a fiber lens, it will destroy or damage your fiber lens. So you want to be very careful not to accidentally do that. If you're buying a lens specifically for the fiber wavelength, then you want to make certain that you're using the fiber wavelength through that lens. Now, if it's a multiple lens that'll work with both wavelengths, of course, you don't have a problem. But 5-inch lens, the 5-inch lens I know we sell is only for the fiber laser. We don't have that type of lens that works with both wavelengths. So you want to be very, very careful, because I know that one is an expensive lens. It's hard to get and hard to have made, that you only use a fiber laser through it. How do you prevent a crash for the first color on the spice rack? In this case, you want to make certain for the spice rack, in order to make sure that it is not going to do it, I will typically set the laser to do not return home. So laser systems have the ability so that it doesn't start over at 0, and then head over to your product. And so wherever you start from is where the laser will start engraving from. So make sure you turn your laser on to where it does not return home. And so basically, as it goes through the process, it is going to start where you tell it to, and then it's going to go to the next color and the next color. If you're not sure, use a sacrifice color. So use a color that is not going to be used, on a product that's 1 second, and then for like 1 second long, and then the laser is going to move the z-axis to that color, and then make the motion, and then it's going to move to the next color. It's kind of going to give you the guarantee so you can kind of control where your lens is or your laser is moving between it. So in that case, most of the time, what I would suggest is just turn it, do not return home. So the head does not, it starts where it left off, and when it finishes, it just stops. It doesn't move back to any home location. So make sure you turn that on. What is the thickness of the wood for the 3D skull? The thickness of the wood for the 3D skull that I ran there was about 3/8 of an inch thick. It wasn't too thick, especially thinner materials like that. You want thick enough material so you can get some nice relief and depth into it. I wouldn't suggest your 1/8 inch material for that, because the relief would go all the way through the material. The thicker you cut, you engrave into, the better. Of course, if you want to cut it with the laser, depending on the type of wood, I wouldn't go more than about 1/2 of an inch in most cases. And then also stick with your very nice tight grain woods like cherry and maple tend to work the best for the 3D. When should you use the honeycomb tray, and when directly on the aluminum base? The honeycomb tray and directly on the honeycomb. The honeycomb or the cutting table is designed for cutting. And most everybody just leave it in all the time. It doesn't matter. It doesn't hurt anything if you leave the cutting table on all the time. Most people will just leave it in case. So you don't have to switch out your table if you're not doing cutting. If you're just engraving on something, of course, you can leave it onto your cutting table, your cutting or your vector grid, your honeycomb grid. Now, if you are physically cutting through the material, I do highly suggest that you leave your cutting table on. But as you will find that you will probably do, as well as most customers tend to do, as well as myself, is just leave the cutting grid on at all times. And then, of course, set products on top to engrave. And then when I do need to cut, it's always ready to go there. So that's what I would suggest. Can you post info on your box to Sandblast? What sandblaster tool do you use, and where do you buy the glass beads? I bought everything, the sandblasting box, just on Amazon. It was an inexpensive, it was like $230. You just go to Amazon.com and, of course, just type in sandblasting cabinet. They even have one that has a little gun that already comes with it, and it was like $230. I also got the sand carving beads from Amazon, but Harbor Freight also sells, I don't think they sell a cavity, but they sell, of course, the gun as well as the beads as well as the different grits of sand. So you can pick it up very inexpensively through one of those two different locations. You mentioned using sand as a fixture for oddly shaped odding. Is there a substance that can be used to make something more permanent that will harden and will not shrink? I'm sure there are. I mean, I've looked at using like plaster of Paris is a good one, because you can actually place some plaster into a a box or something like that, and then place the product down into it until it's completely hardened, and then pop your product out. Kind of gives you that three-dimensional mold that you can then place that product into it. And it is kind of permanent. That's a good potential future laser hack, but I haven't actually done any type of video footage for that. I'm sure there's other types of plastics and polymers that you could do that with. Any type of hardening, epoxy may work, where you got the two-part epoxy, place it into a tray, and then, of course, let it sit for a little bit, and then set your product onto it. Kind of sits down, and it's going to kind of give you that molded component. Once it's hardened, you prop your product out. I would, of course, coat your product that you're creating with in some type of release, oil or something like that, so it doesn't stick or permanently bond itself to your tray. But it's a good example, definitely a great question, and possibly a future laser hack based on that type of question, because I have gotten that one quite often. I will see about maybe working up some different products and working with some different products to see what I can find out for you. So stay tuned. Can a Speedy 300 be upgraded to the camera system? And the answer is absolutely. It is a simple little process. If you don't actually order it from the factory, it can take about 30-40 minutes to install. You can do it yourself, or of course you can work with your local sales or service department to have them come out and install it for you. But definitely our Speedy 300 and up, all of the rest of our Speedy models, as well as our SP models, will support the camera system. If you are using our Speedy 100 or our Rayjet series, they do not support the camera system, just so you know. Will this be available at a later time? I assume this seminar? Absolutely. The link that you actually signed up for, you can use that link over the next month to access these laser hacks. It will not be posted online until this time next month. We tend to have a 1-month lag, so that you folks that spent the time to come see it or sign up for it have the ability to watch it in that first month. And so, yes, it will be posted online at this time next month publicly. What cleaner is best way to clean the honeycomb grid? Great question, and another one I get all the time. My suggestion for that is to use common everyday oven cleaner. It's designed to take baked on grease and grime and baked on debris and residue away from it. I do suggest not to leave it on too long, because it will actually take the coating off of, say, your anodized rulers. So spray it on, it goes on in a foam, take it out and hose it down, and it will reduce the amount of residue that's forming versus trying to remove or clean in between each one of the honeycombs. Honeycomb tables too, I mean, aren't that expensive. They're, $100, a couple $100 depending on the size. And so I do suggest over time, just to keep your product and quality better, is replace them. The other thing that you can do with honeycomb tables is you can take your cutting table apart and turn your table over and rotate it, so that you can kind of get more life out of it, and less residue is going to form in the area that you don't tend to cut as often. So there are a couple different things that you can do to kind of prolong the life, but it is really a consumable, and I do suggest that contact your manufacturer and get a replacement honeycomb every couple of years, depending on what you run. If you're running a lot of highly resin-based materials, you may need to do that more often, or try the oven cleaner. It definitely is going to prolong the life. When will the Ruby software be released in full? Right now, for those of you who don't know about the Ruby software, is an add-on. It is a software that we have released as a beta. The latest version of Job Control 11.4 has the offshoot and your ability to use Ruby. Ruby is a standalone web-based software currently. It is only on your system for now, but Ruby will give you the ability to do some basic editing in the designing basically the driver. So you can size, you can scale, you can add text and stuff like that. And eventually you'll be able to run this remotely once the full release is going to happen. Great software, great potential, but we're looking at sometime later next year for the full release. I believe the last I saw, the estimate was sometime next year. I can't guarantee any time on that because I don't know for sure, but I do know it was in 2021. Thank you. This has been really informative. We appreciate you and your time to do that. You're very welcome, Jennifer. Thank you for watching. All right. Well, that's it. Thank you so much for watching. This concludes the 2020 Third Thursday seminars. Don't forget to follow me on YouTube on our laser hack series. And so I will we release one every 2 weeks, and just stay tuned and keep a close eye for future laser hacks. All right. So thank you. So everybody, Laser Dave signing off.